This is the third lesson of Unit 2. Okay, so today we started with a warm-up. Let me move this. So you're supposed to rewrite or add a second equation to make a system of equations where we have one solution, no solution, and infinite solutions. So pause the video, take a moment to do that warm-up, and then play to check your answers. Okay, so the original equation y equals 3x plus 1, to have one solution, that just means that the line needs to intersect with the original line. So really there's lots of answers here for part A. Really just you need something that does not have the same slope, 3, and a different y-intercept, and also something besides the exact same equation or a multiple of that equation. So like I said, really anything. I'll just do that. That's one example that would have one solution because the slopes are not the same. Okay, so as long as your slopes are different, or if the slope's the same, you want to have a multiple of that equation. So that's our answer for A. B, no solution, that's when the lines are parallel. And so we do want the same slope this time with a different y-intercept. So as long as I have y equals 3x and then something besides plus 1, I'm fine. That would be an example of a system of equations that has no solution because the lines are parallel. And lastly, infinite solutions. Well, when I graph this original line, I then want to graph my new equation, and I want to see only one line, because I basically just want this equation, but not the exact same thing, because then that wouldn't be a second equation. I want that equation with a multiple. So as long as I multiply that y, x, and 1 by something, and it's the same number, that would be fine. So something like 2y equals 6x plus 2, that would be fine. Okay, and I didn't specify the form that this line needs to be in, so in this form is fine, but if it was in standard, if I asked for standard form, we need to get that into standard form or whatever form we were asking for. The key with this one is you want the equation to be the same when simplified, but look different than the original did. So look different than the original did by multiplying by a common number, common factor, all the way through. And that would give infinite solutions, because if I graph both of these, I'm looking at the same line, and that same line intersects itself infinitely many times. I also in class referred to, there was a question in the homework that came out infinite solutions when you were solving 3 equations and 3 variables. You ended up with something like 0 equals 0. Well, that's a true statement, and the variables dropped out. So when you have 0 equals 0, that's infinite solutions, because that line intersects itself infinitely many times. Or in the case of the homework where it was 3 equations and 3 variables, that plane intersects the same plane or itself infinitely many times. So infinite solutions there. Same thing with the no solution. That's in this case when it's 2 equations and 2 variables, that's parallel lines, but with planes it would be parallel planes. So planes can be parallel as well, which would mean no solution. Okay, so the next thing we did was we moved on to classwork, and classwork today is in your packet, in your Unit 2 packet. So you'll need to turn to page 11 so you can see what I'm looking at there on page 11. Page 11 is graphing a system of inequalities. So we're going to graph all 4 of those inequalities on the same coordinate plane that's provided there on page 11. So what we want to do, rather than getting these in slope-intercept form and plotting the slope and then, or plotting the y-intercept and then using the slope, we're going to find the x and y-intercepts of these. And later when we get to the next topic, of linear programming, I'll explain why that's important that we graph these inequalities that way, using the intercepts rather than using the the y-intercept and the slope. So the first one, 2y, and it says greater than or equal to, but we're just looking at the equation itself right now. Because we're looking for the intercepts. So I just made it equals rather than greater than equal to. I'm going to find the x and y intercepts. So if I find the x-intercept, I'm putting 0 in for y and solving for x. So 0 equals x minus 3, which means 3, 0 is my x-intercept. Secondly, the y-intercept. So I'm putting 0 in for x and solving for y. So 2y equals negative 3, which means y is equal to negative 3 halves, or negative 1.5. So 0, negative 1.5. Next equation, again, it's an inequality, but I'm going to rewrite it as an equation. X minus 2y equals negative 7. So solving for the x-intercept, putting 0 in for y. So x is equal to negative 7. So negative 7, 0. Finding the y-intercept, putting 0 in for x, and solving for y gives me negative 2y equals negative 7, which means y equals positive 7 halves. So 0, 3.5 is the y-intercept. Next, third inequality, which I'll make an equation. Y is equal to negative 2x plus 6. So we already can see that one's in slope-intercept form, which means the y-intercept we know, but let's get the x-intercept. So 0 equals negative 2x plus 6, which means negative 6 is equal to negative 2x, which means x is equal to negative 3. So negative 3, 0. And we know that the y-intercept is 0, 6 without having to do any work for that one. The last one, number 4, negative 9 equals 2x plus y. Finding the x-intercept, substituting 0 in for y. So x is equal to negative 9 halves. So negative 4.50. And then finding the y-intercept. So negative 9 equals 2 times 0 plus y. So negative 9 is equal to y. So 0, negative 9. Okay, so now we have all of our x and y intercepts. So we're going to take those one at a time now. The first inequality has an x-intercept at 3, 0, and a y-intercept at 0, negative 1.5. So on that coordinate plane, you need to go ahead and graph those 2 points or plot those 2 points and then draw in a line. Now, the inequality for that one was greater than or equal to. It was actually originally greater than or equal to. So you'll shade above that line. Next, you'll plot the x and y intercepts for the second inequality. So negative 7, 0 and 0, 3.5. And that one, we're going to have to figure out what it would be in y equals form because it was not. So we had x minus 2y is greater than or equal to negative 7. So if I'm solving for y, I'm going to subtract x. And then I'm going to divide by negative 2. So because I just divided by negative 2, in y equals form, I flip the inequality, and it becomes less than or equal to 1/2 x plus 7 halves. So because it's less than or equal to, after I plot these 2 points and draw the line in, I will shade below that line. Next, number 3, the intercepts are, whoops, it looks like this should be a positive 3 because negative 2 times positive 3 is negative 6. So positive 3, 0, and 0, 6 are my x and y intercepts. So go ahead and plot those. And then our inequality is, this one already is in y equals form. It's less than or equal to. So after we plot those 2 points and draw the line in, we'll shade below that line. And the last one, the x-intercept is negative 4.5, 0, and the y-intercept is 0, negative 9. And go ahead and plot those and draw the line. And our inequality for this one says negative 9 is less than or equal to 2x plus y. So if I get the y by itself by subtracting 2x, I have the y on the right-hand side. So remember, we're reading from right to left on this one. So it says y is greater than or equal to, which means I will graph or shade above that line. Okay. After plotting all those points and graphing the lines and then the shading, you should get, and I'm just going to do a real quick sketch here, but you should get a graph that looks like, so here's 3, 0, and 0, negative 1.5. Okay. And that one we said is above. Okay. The next one we said 0, 3.5. And we said negative 7, 0. Okay. And we said on that one that it is below. The next one we said 0, 6. And we said 3, 0. So that looks like that. And we said below. And lastly, we said 0, negative 9. And we said negative 4.5, 0. Right about there. And we said above. Okay, so kind of hard to see here, but we have this final region that is definitely a quadrilateral. Okay, that's the region that's darker, that quadrilateral. And we talked about in class, we could take time to find the slopes of these sides. If the adjacent sides have opposite reciprocal slopes, that means the sides are perpendicular. And if the opposite sides have the same slope, that means the opposite sides are parallel. We could take time to prove that this is a rectangle or a parallelogram, but we're not going to do that. The point was getting practice with putting multiple inequalities on the same coordinate plane. So your graph should end up looking something like that on page 11. Okay, the next thing we did was we started the linear programming problem on page 12. And on page 12, we have this toy factory. And if you read that problem a moment, take a moment and do that, then you should be able to take the information from that problem and fill in the chart on page 12. So if I have wheels, seats, and gas tanks, and I have cars and trucks, I'm just doing this very quickly, and a total. So the wheels from the problem, 4 wheels are required for a car, 6 wheels are required for a truck. and the total in the storeroom is 36. The seats, let's see here. Each car needs 2 seats, and each truck needs 1. And there are 14 seats. And lastly, the gas tanks, 1 for cars and 3 for trucks, and the total is 15. Okay. So the first thing we did after filling out that table is we talked about how we would fill out the second table in part 2. And basically that's just a series of guessing and checking and trying which numbers of cars and trucks are possible with the given wheels, seats, and gas tanks. For example, we started with 0, 0, 0 cars, 0 trucks. And we realized very quickly that's possible, but the person's not going to make any profit. So yes, we do have enough parts for 0, 0. Then we moved on to 0, 1. And we looked to see if that was possible, if we had enough parts. Then we kept going, and after trial and error a little bit, we found that 0, 0 was possible, 0, 1 was possible, 0, 2 was possible, 0, 3 was possible, 0, 4 was possible, and 0, 5 was possible. When we tried 0, 6, it was not possible. There were not enough parts to complete that order. So when we reached our limit and got as far as we could with 0, 0, 5 was the highest, then the next thing we tried was 1, 0. And we found that that worked. And we continued on 1, 1, it works, 1 car, 1 truck. Then we found 1, 2. We were getting to the end of our table here, but we just kept going, 1, 2. And then we have 1, 3 and 1, 4, they all work. And if you take time to figure that out, you'll see that we have enough parts for 1 car and 4 trucks. But then when we tried 1, 5, no, not enough parts for 1 car and 5 trucks. So then what we did was we moved on to 2, 0, 2 cars and no trucks. And we would continue on in that fashion, 2, 0, 2, 1, 2, 2, 2, 3, 2, 4, so forth, until we reached our maximum number of trucks with 2 cars, and then we would move on to 3, 0, and so forth. Now, what we discussed in class is that would take a long time to try all of those to get all of the possibilities. So there's a more efficient way, and that is that we're going to take the information that we put in this table and we're going to create some inequalities instead of trial and error with the points. So on the next page, on page 13, you're given an XY coordinate plane, and it says that we're just using that first quadrant. We're only given the first quadrant, and the question is why? Well, they're telling you that the number of cars are on the x-axis and the number of trucks are on the y-axis, and the answer to why we only need the first quadrant is because we can't have a negative number of cars or trucks. So that's why we're using that first quadrant. So if I'm looking back on my table here now, and I'm realizing that cars are x and trucks are y, number of cars x, number of trucks y, then I can come up with some inequalities to represent that information. Basically, this table is telling us that every car requires 4 wheels, or in other words, 4 wheels per car. Well, in math terms, we know that that's 4x. And every truck requires 6 wheels, so in math terms, we know that's 6y. And we want a total, and the total can be 36. We can use all 36 wheels or less. We cannot use more than 36. So we talked about the fact that the inequality for the wheels would be 4x plus 6y is less than or equal to 36. So the second inequality would involve the seats, and that would be 2x plus 1y is less than or equal to 14. And the last inequality would involve the gas tanks, and that would involve x plus 3y is less than or equal to 15. Okay, and this is at the point where we were getting to pretty much the end of class. I think the last thing that I asked students to do was to figure out what the x and y intercepts are for each of these 3 inequalities. And in the one class, I think that's as far as we got. We just found the x and y intercepts. And we're going to pick up with this problem tomorrow. I think some of the other classes, after they found the x and y intercepts, I then had them graph them because we had a little bit more time. So go ahead and just find the x and y intercept for each of these three inequalities, and then go ahead and plot them and graph the lines and do the shading. And then we will pick up with this problem tomorrow in class to finish up linear programming.